Okay, these are the solutions for the practice questions continued, so numbers 5 and 6. So a regular 52 card deck is shuffled, 2 cards are placed face up, and when a third card is given to you, if that card falls between the 2 cards that are face up, you win. So what is the probability that the player will win for each pair? So A, we have the 2 of hearts and a 7 of spades. So for 5A, the 2 of hearts and the 7 of spades. Okay, that means the cards that will make me win will be the 3 of hearts, the 4 of hearts, the 5 of hearts, and the 6 of hearts. It has to fall between, right, of hearts. I could also win with spades, so I can get a 3 of spades, 4 of spades, a 5 of spades, and a 6 of spades. And then I can also win with the numbers of the cards from different suits. So I could get a 3 of clubs, a 4 of clubs, a 5 of clubs, or a 6 of clubs. And lastly, a 3 of diamonds, a 4 of diamonds, a 5 of diamonds, or a 6 of diamonds. So all of those cards would actually allow me to be a winner in this particular sequence of the 2 of hearts and the 7 of spades. So if I think about how many that is, right, I have 4 times the 4, which will give me 16. So there's 16 possible cards that could make me win, but I'm not actually out of 52 because 2 cards have been removed. So if you think of your 52 minus those 2 cards that were removed, now I actually have, out of the total possible outcomes, it would be out of 50 in this case because 2 cards have been removed. So a 16 out of 50, that will give me a probability of 0.32 or 32%. So I have a 32% chance of being a winner when there's a 2 of hearts and a 7 of spades showing. Okay, let's go to B, a 5 of diamonds or the king of clubs. So for B, 5 of diamonds and the king of clubs. Don't worry, I'm not going to be drawing my pictures for all the answers. So what will allow me to win between these? If I got a 6 of diamonds, a 7 of diamonds, an 8 of diamonds, a 9, a 10, a jack, or a queen, right? If I think of all of my diamond suits, I can do my club suits. It's the same thing, 6, 7, 8, 9, 10, jack, queen of my clubs. And then I'd have the same thing for my other suits that are not included in this one, but the numbers fall in between, of my hearts and of my spades. Okay, so just so I don't count those as numbers. 1, 2, 3, 4, 5, 6, 7. There are 7 cards in each group of my 4 suits. So 7 times 4 will give me 28. And if I think of that 28 as the probability of what my desired outcome is, out of, and if you remember back to this question, out of 50, not out of 52. Those 2 cards have been removed, so it's out of 50. So 28 out of 50 is actually a really good percentage. It's 0.56 or 56%. That's a really good chance of me winning for that particular setup. Okay, for C, it is an ace of clubs and a 4 of spades. So ace of clubs, 4 of spades. That means ace, 2, and 3 would work. And then the 2 and 3 of my spades would work. 2 and 3 of diamonds would work, and let's say 2 and 3 of hearts. Or you could have just done it actually as your 2 times your 4, right? 2 possible ones that would be desired outcome times the 4 suits, which is going to equal 8 out of the 50 possible cards that could be selected. Not as good of a chance on this one. If we're doing 8 out of 50, that's equal to 0.16 repeated, I think, or about 16%. Okay, so not as good of odds on that one. And then when we go to D, what are the chances of me getting a card between a 10 of diamonds and a jack of clubs? A 10 of diamonds and a jack of clubs. So when I look at this, there is no card that will actually fall between. I can't get anything between a 10 and a jack in any of the suits. So that gives me a 0 out of 50 chance. Or if we look at that, that's our 0% chance of winning if those were the two cards that happen to be drawn. Be an unfortunate situation. Okay, question 6. Each letter of the word win is written on a piece of paper, and those papers are placed into a hat. And then you make 3 picks without looking, and you don't replace what you pick. You place the letters from left to right in the order that they're selected. And if you pick the letters that spell win, you get a prize. So what is the probability of winning that prize? Okay, so if we think for question 6, right, I have the word, or the letter, excuse me, W, I, and N on pieces of paper. Okay, this I'm going to actually use a tree diagram to show. So the W, the I, and the N. So I've taken out one of those, and now I need to figure out what's remaining. So let's say I pull out the W on my first pick. That means what's left over is an I and an N. Let's say I picked out the I on that first pick. That means I have a W and an N left. And let's say I picked out the N. That would mean I would have a W and an I left. Okay, so now we're going to go through and figure out if I picked out the W on my first pick, if I picked out the I on my second pick, what is left over would be an N, right? If I picked out the W, the N, what's left over has to be the I. If I picked out the I, then the W, the N has to be left. If I picked out the I and the N, W, the N, the W, there's an I left over and a W left over. So what is the probability, that's what question A is asking, of you actually winning a prize? And that means I have to pick out the W, the I, and the N in that order. So this sequence right here is my winning sequence. That only happens once out of 6 possibilities, right? If that's one option, that's 2, 3, 4, 5, 6. Right? There's 6 possible outcomes. If for me to actually win is only a 1 out of 6 chance, which isn't terrible, 0.16 repeated, or about 16.6% chance. Okay, so I have a 1 in 6 or 16.6% chance of winning when I just take them out one at a time and don't replace them. Question B is asking though, what if you do replace the papers after each pick? Is the probability of winning increased or decreased? Explain. So this takes up a bit of space. I'm actually going to use a different paper for B. Okay, so for 6B, I obviously have my first pick of, I'm going to space these out because I'm going to need the space, W-I-N. Okay, now I replace them once I've put them in, which means I have now, again, 3 options. Okay, so I could pick a W and then put the W back and pick a W again, right? You're going to end up having 9 options on that second pick of what you could have as your combination. And then because it's a 3-lettered word, I have to pick a third time. Okay, and again, each of these has 3 options again for the combinations. So W-I-N, W-I-N, so on and so forth, all the way down. But I still need to get that combination of picking a W and then picking an I and then picking an N, which only happens in that order. Remember, it has to be in that order, which only happens that one time. If I start with the W and then pick a W, that doesn't get me the combination. If I start with the W and get an I, that's great, but I still have those chances of getting an I and a W. I need to get W, I, and N in that order on the first, the second, and the third pick. So right now that probability is 1. And if I count all of these up, or if you can actually just do it as the multiplying each section. So there was 3 options in here, and there was 9 options in here. That means there's actually 27 possible outcomes. So it's a 1 out of 27 probability that I would get this prize because I picked out the W, the I, and the N. So when it's asking, is your probability of winning increased or decreased? If I'm kind of comparing, if I remember the other one was 1 out of 6, that was my original percent chance. And now I'm looking at 1 out of 27, which is 0.037 or 3.7%. I have a much less probability of getting those letters in that order when I put the papers back in. Okay, so my probability has decreased drastically, actually, just by replacing the papers. So if you were given a choice, do you want to put the papers back? You would say no, because it is a better probability for me just to pull them out and keep them out and win that prize. Okay?